Hello ladies and gentlemen, this is Miss Skokan. Back in chapter 5, in this section we're looking at inequalities in two triangles. If you remember in section 5.5 we were looking at inequalities in one triangle. Our objective is apply inequalities in two triangles, and our vocabulary is Hinge Theorem and Converse of the Hinge Theorem. As always, it's time for you to work on the warm-up questions and then turn the video back on when you're ready to check your answers and move forward. Both of these questions came from our previous section 5.5, Inequalities in One Triangle. If you have any questions about either one of these two, please bring them to class and we'll discuss. The Hinge theorem says, if two sides of one triangle are congruent to two sides of another triangle. Let's take a look at the diagram and see. So we have one tick mark on the red triangle, one tick mark on the blue triangle, two tick marks on the red triangle, two tick marks on the blue triangle. Okay, so if two sides of one triangle are congruent to two sides of another triangle and the included angles are not congruent, then the longer third side is across from the larger included angle. Meaning, now again, let's look at the triangles in the diagram. We see that we have two pairs of congruent sides on the two triangles, but if the measure of angle A is greater than the measure of angle D, then that means that the side opposite angle A on triangle ABC is going to be longer, and the side EF on triangle DEF is going to be shorter. So that's the Hinge theorem. If you have a larger angle, you're going to have a longer side. So again, we're comparing two triangles, and they are not congruent triangles. Just remember, because we do have a difference in an angle and distance, but what we do have the same is two pairs of congruent sides. Okay, the converse of the Hinge theorem. Remember, converse is always going to be where we reverse the hypothesis and the conclusion. And it says, if two sides of one triangle are congruent to two sides of another triangle, and once again, so we see one tick mark on triangle GHJ and one tick mark on triangle KLM, then we have two tick marks and two tick marks. So if two sides of one triangle are congruent to two sides of another triangle, and the third sides are not congruent, then the larger included angle is across from the longer third side. So once again, this is reversing the hypothesis and the conclusion, and it is saying if you have a longer side, then it's going to be across from the larger angle, and the shorter side is going to be across from the smaller angle. Converse of the Hinge theorem. All right, let's take a look at an example. Example number 1, using the Hinge theorem and its converse. Question A says, compare in a less than greater than way the measure of angle BAC and the measure of angle DAC. So if you notice, we have two pairs of congruent sides on the two triangles, but the third sides are not congruent. The converse of the Hinge theorem tells us that the larger included angle is across from the longer third side, and that means that the shorter side is going to be across from the smaller angle. So now we're ready to answer the question. The measure of angle BAC is greater than the measure of angle DAC. Let's move on to question B. Once again, we've got two pairs of congruent sides. Now let's take a look at what else we've got. You'll notice that we have a linear pair, and we have the measure of one of the angles, angle EHF. To find the other one, of course, all we need to do is do 180 degrees minus 82 degrees, giving us 98 degrees. So we've got the measure of that other part of the linear pair. So this meets the definition of the Hinge theorem, which says if two sides of one triangle are congruent to two sides of another triangle, and the included angles are not congruent, which they're not, one is 82 degrees, the other one is 98 degrees, then the longer third side is across from the larger included angle. So the length FG is greater than the length FE. Question C is just a little bit different because here we want to find the range of values for K. So again, let's check and see if it meets the definition requirement. We have one pair of congruent angles and we have, or I'm sorry, sides, and we have another shared side, so we know it's congruent to itself. Then we take a look at the sides opposite the included angle, and 38 degrees is opposite 19, a length of 19, and 5K minus 12 is opposite a side of length 18. So we know this 38 has to be larger than 5K minus 12. So what we're going to do is set up some inequalities. 5K minus 12 degrees needs to be less than 38 degrees. And 5K minus 12 degrees, in order for us to have a triangle, has to be greater than 0 degrees. Now we solve the inequalities and then find the solution for the and. So when we put this on a number line, we graph numbers that are less than 10 and numbers that are greater than 2.4. Because this is an and compound inequality, that means that we just want the overlap between them. So our K, our number K, can range between 2.4 and 10. On the next page, there are 3 questions on a Now You Try for you to practice this new skill. As you work on these, look back on the Hinge theorem and the converse of the Hinge theorem if you need some help. Also look at the examples on page 11 if you need some help. So go ahead and turn the video off now and turn it back on when you're ready to check your answers. If you have any questions from any of these 3 problems that you'd like to address in class, don't forget to ask and we'll go over your questions. Example number 2 says, the angle of the swings in a circular swing ride changes with the speed of the ride. The diagram shows the position of one swing at 2 different speeds. Which rider is further from the base of the swing tower? Explain. Okay, so we need to use our Hinge theorem to help us out here. And what we notice is the distance to the ground is going to be the same on both triangles, and the length of the rope for the swing is the same on both triangles. In terms of the angles, we have the smaller angle on the left and we have the larger angle on the right. That means that we have the longer side length across from that larger angle and the smaller or shorter side length across from the smaller angle. So which rider is further from the base of the swing tower? Our answer is the rider on swing B is farther away from the base of the swing tower, because the third side of the triangle is longer when the included angle is larger. Question 2 asks, when the swing ride is at full speed, the chairs are farthest from the base of the swing tower. What can you conclude about the angles of the swings at full speed versus low speed? Explain. And we recognize that if the chair is farthest away from the base of the swing tower, then that's going to have the largest angle. That brings us to the end of our notes for this lesson. And next is your independent practice. So as always, if you have questions, bring them to class. Otherwise, see you in class.